Okay, so we're going to look at our example here. It says we've got students pulling a water balloon back in a water balloon launcher. When they release it, the launcher applies a force of 60 newtons to the 0.5 kilogram water balloon for 0.4 seconds. So the first part wants us to calculate the impulse on the water balloon, and we're going to show all of our work. So we're going to start with the equation. So to find impulse, we want this one right here. So that's the one that we're going to write down right there. Now, the first thing we have to put in there is the force, which is 60 newtons, and we're going to multiply that by the time, which is 0.4 seconds. When we do that, we get 24. I kept the positive there, and then we're going to write down our unit, which was Newton seconds. We got the newtons and the seconds. We multiply to get that Newton seconds. Now, this next one says show work if necessary. What is the initial momentum of the water balloon? When it says show work if necessary, that means that we can probably think this through. So let's think about it. The initial momentum, when they pull the water balloon launcher back, and then we let go, and it applies a force, to begin with, my water balloon isn't moving. So it's at rest. So that means it's not moving. There is actually no momentum, because when you're not moving, the velocity is 0, anything times 0 is 0, so my initial momentum is actually 0. I didn't actually show any work. I mean, I guess I kind of showed some work because I showed that it is here at rest. So that's enough for me. If all you did was write down 0, whoops, I wrote down the wrong unit. Do you see that? I left off the kilogram meters per second. If all you did was write down 0 kilogram meters per second, that would be enough because that's the answer, okay? So next question, what's the final momentum of the water balloon? Now this one, I don't really have to do much calculation here either. I know that this, let me circle it for you. I know that this right here is my change in momentum because of this right here. The impulse is the change in momentum. And I had 0. I'm adding that to my momentum. So if I do that there, impulse is the change in momentum, then I went from having 0, now I'm going to have 24 kilogram meters per second. So that's all I really have to show there either. Again, those two problems, I'm just thinking through things. The last one, I need to calculate the final velocity of the water balloon. Now this one, remember, you're going to have more equations than just these in this box on the test. And so when I'm trying to find the velocity from the momentum, I can use this equation, v equals p over m. I'm going to be plugging in that momentum that I have now at the end when the balloon leaves the water balloon launcher. I'm going to divide by the mass, which was 0.5 kilograms. When I do 24 divided by 0.5, I get 48. And the unit for velocity is meters per second. And so that's an example of working through one of these. If you need help working through the practice on these, make sure you ask. Thanks for watching.